This is the rest of the video here to help you through quiz 2-2. A lot of these I didn't really feel would be necessary to show you again, but I am going to go through just in case someone needed it here. All right, so now this one has another inverse problem here. So notice this doesn't say tangent right there, so there's no possibilities of canceling out. So what I'm going to have to do is just evaluate that. So I'm looking at that question there, where is the tangent going to give me 1? And so notice the tangent would be 1 there at pi over 4. And it would also be 1 at 5 pi over 4. So we kind of have to decide, well, which one are we looking at there? Well, if we're doing inverse tangent, remember inverse tangent can only go from negative pi over 2 to pi over 2. So that eliminates that one. So really what we're talking about is pi over 4. So my answer is not pi over 4, but that's sort of the inside part there. So now I would be finding the sine of pi over 4, which is just the y coordinate there. And so that was just going to give me square root of 2 over 2. Okay, next one's very, very similar here. So again, these are not inverses of each other, so I actually have to evaluate this part right there. So we're looking for where is the sine negative 1/2, and so let's notice down here the sine would be negative 1/2. Let's kind of see where else the sine would be negative 1/2 over here in the third quadrant. Now, if we're doing inverse sine, remember inverse sine, or really nothing goes into the third quadrant. So that kind of eliminates that. But inverse sine, again, just like tangent did in the last problem, goes from negative pi over 2 to positive pi over 2. So we have inverse, or we have sine is negative 1/2 there at 11 pi over 6. Now, so this would be the cosine now of, really I should say negative pi over 6 instead of 11 pi over 6 there. And so the cosine there is just square root of 3 over 2. Okay, next one's real similar. Again, these are not inverses of each other, so I can cancel them out. All right, so I'm looking for where is the cosine, the square root of 3 over 2. And so we've got it there at pi over 6. And we've also got it at negative pi over 6. But recall with inverse cosine only goes from 0 to pi. And so that's just the first and second quadrants. So that one wouldn't work out. Now, so where is cosine square root of 3 over 2? It's at pi over 6. And so now I'm going to do the tangent of pi over 6. Okay, now chances are you might have that one memorized. All right, in case that we don't here, we can find tangent by doing sine over cosine. So that would be 1/2 over square root of 3 over 2. Now we multiply by our reciprocal here. So 1/2 times 2 over square root of 3 would give me 1 over square root of 3, which would rationalize to square root of 3 over 3. So you have memorized your tangents. You probably need to do that by now. That one's square root of 3 over 3. This one up here is just square root of 3, and of course that one's 1 on your tangents there. Now, let's see the next one here. Now we're looking at an identity. This one's actually fairly simple. Now, let's look at the last step and see if the last step kind of makes sense on each one. So let's start with that one. So in this case, if I said cosine times sine over cosine, let's see, how could that give me cosine times cotangent? Well, what they're saying there is that sine of theta over cosine of theta is cotangent of theta. That's not right. Sine over cosine would be tangent. So A's not working out by the last choice, or by the last step. Okay, now let's see the next last step, or on choice B here. So I've got this idea here that I've got negative sine times sine theta over cosine theta would be equal to cosine times cotangent. And so let's see what they're doing there. Again, sine over cosine wouldn't be cotangent, and I'm not sure how they're changing negative sine here to cosine. And so that doesn't look exactly right, although I'm not exactly sure that that's wrong. So I'm not going to eliminate the choice there. I'll leave that one up. Now, the next one, all right, notice I believe is the same thing as the first choice. So I'm just looking here. Cosine over sine is cotangent. It is a little bit different there. And so that does actually make sense. Now, if we look at the last choice, we kind of have the exact same thing. So the last two have the exact same steps. So the only one that's throwing me off here is this last one. Not exactly sure where we're getting this idea from. All right, but let's see if we can make the either choice C or D work. Okay, let's look at the first steps now. Okay, so on C, let's see what they're doing here. Let's see if this kind of makes sense here. We've got cosecant of theta minus sine of theta. So cosecant, that makes sense. That could be written as 1 over sine. So that seems okay. Now let's look at the first step in choice D. Now this one they're screwing up on. They're saying cosecant there is 1 over cosine when it should be like choice D when it should be 1 over sine. So the first step's kind of ruling out D. Now let's see if we can make C work all the way through now. All right, so I'm going to pick up on a step here on choice C, and let's see if we can make this work. And so let's see what's happening in my third step. Okay, so they've got 1 minus sine theta minus sine theta is cosine squared over sine theta. So let's see if we can figure out how to make that work. So we got 1 sine theta minus sine theta. Now, the only thing that kind of comes to mind there, it would be probably to find, since one of them's a fraction, would be to find a common denominator. So the common denominator would just be sine theta. So notice here, I wouldn't have to multiply by anything, so my 1 would bring down. Now, in this case, remember my denominator there is a 1, so I would have to multiply by sine theta in my numerator and my denominator there to make that happen. And so that would give me sine theta on the bottom, and then on the top here, I'd get sine squared theta. Now, let's look. That's not exactly what they have there, but what they're doing is using a Pythagorean identity. 1 minus sine squared there is cosine squared. So that makes sense there. And so now let's see if this step looks okay. From here to here, now that looks perfectly okay. All they're doing is taking cosine squared and breaking it up into a cosine times a cosine. So it was choice C, and there again on choice A, I'm not exactly sure what they're doing on that last step, but it didn't look right, and that's why I continue to work out choice C. It was just to make sure that everything was okay. All right, let's look. Next one now. Okay, so we've got another one. Maybe we can cancel this out. There again, it's going to be about whether or not this lies in a nice quadrant for me. So I need to figure out, is the tangent of negative 5 pi over 14 going to be in the fourth or first quadrant? Now certainly it wouldn't be in the first quadrant because it's negative. Okay, so you guys are going to have to really think with me here. And so if we're going negative in the direction here with this, if we went all the way around here to the third quadrant, that would be negative 14 pi over 14. And so halfway would be negative 7 pi over 14, which is still just negative pi over 2, but I'm thinking of these in terms of 14s. And so what I'm trying to do is figure out what quadrant would that lie in. Well, from negative 7 to negative 14, it would be in the third, which doesn't work. But from negative 1 to negative 7 there, which negative 5 would lie, it would definitely here lie in the fourth quadrant. Okay, so now if that's in the fourth quadrant, then it's perfectly okay that I can do that. And so my answer is going to be negative 5 pi over 14. So there again, we can do that, but we've got to check. Was that in the right quadrant? Was it in the fourth or the first? It was in the fourth, so I could cancel those out. Okay, next one. Now this one's probably the simplest identity of all here. And so I could probably do this one by myself, but I'm going to look at the multiple choice strategy here. So let's notice the last steps. And so in this case, those cosines would cancel and give me sines, so that looks perfectly okay. Okay, I believe the next step does the same thing. I believe all the last steps are correct. So those sines would cancel out. Oh, that's not right. And so that should leave me with cosine right here instead of sine. So B's not working. Okay, let's check this one. I think this one's the same thing. The sines would cancel out and leave me with cosine, not sine. So C's not working. Now let's look at a first step, or let's make sure this one's okay. The last, their choice D, those cosines would cancel and give me sine. So that one's okay. Now, let's look at the first steps here. So let's go back to A, and let's check out my first step. And so they're basically changing tangent to sine over cosine, which is okay there. But then all of a sudden cosine of theta goes to sine of theta. And so something went wrong right there. I don't know exactly what they did or was trying to do, but I don't think that's working here. Now let's check the first step on here just to be sure. And so here they go, tangent of theta is sine of theta over cosine of theta. And then, so that makes sense. They didn't change that one to cos to sine there. So that looks okay. Now let's verify it. And so let's see if we can kind of tell what's happening on the second step. So from here to here, they basically just multiplied it out. Or basically what could happen is sine times cosine gives you sine cosine. And so that makes sense. So that would be choice D. That would maybe be one where I think the idea would probably be to work it out yourself instead of trying to figure out the choice there. It would be actually faster to work it out yourself. Okay, now this one's a little bit different here. This is another inverse problem, but notice they've got cosecant out there. So that's maybe something that might throw us off. Now, inside here, we've got inverse tangent of 1. So where is the tangent going to be 1 at? And so that would be at pi over 4. Now, it couldn't be at 5 pi over 4 because that's in the third quadrant. Okay, so now what we're looking at is the cosecant of pi over 4. So understand pi over 4 is not my answer. Pi over 4 would just be the inside part right there. Now, the cosecant of pi over 4, remember cosecant is the reciprocal of sine. Sine is the y coordinate, and so it would just be the reciprocal of square root of 2 over 2. So that would just be 2 over the square root of 2, which would rationalize to 2 square root of 2 over 2. That's a lot of 2's. And then the 2's cancel, and it just gives me square root of 2 there. Okay, next one, we're doing the inverse cosine of the cosine of 7 pi over 6. Now, this is one here where I could maybe look at to see if they would possibly cancel out here. Well, let's look at this and look at what quadrant that would be in there. And so at 7 pi over 6, all right, notice the cosine there, well, you know, if you look at that, that's in the third quadrant. And so I can't do the inverse cosine of that that's in the third quadrant. So this is one that I'm going to have to actually do step by step here. So let's figure, so in other words, I can't cancel out the cosines in this case. So the cosine of 7 pi over 6 is negative square root of 3 over 2. So now I'm going to do inverse cosine of negative square root of 3 over 2. And so that's asking the question, where is cosine negative square root of 3 over 2? And I can't say pi over 6 because it's in the third quadrant. So I just need to find a different quadrant to go to. And so let's find out, well, where else would cosine be negative square root of 3 over 2? And so right there works out. And so that would actually be at 5 pi over 6. Okay, next one is an identity one here. So let's go looking at sort of last steps here. Looks like they've changed everything like in the first steps from sine to cosecant, just kind of observing that. Now let's look at the last step. So let's see if this makes sense. Now notice they have cosecant of theta in both denominators, so those would cancel, but they've made a mistake here. So on the top should be cosecant minus 1, not plus 1. So A's not working out. Okay, on B, we could do the same idea there, but now they did it correctly. So B looks okay. Now choice C, let's see, these would cancel here, just like that. But then all of a sudden, secant theta plus 1 changes to cosecant theta plus 1. And so they're changing secant to cosecant, so that doesn't make any sense. So it wouldn't be choice C. Now, I believe the next one here kind of does what the first choice did. Again, those cosecants would cancel, but then that should have been cosecant theta minus 1 right there, so that one didn't work. So I've actually got this one just by looking at the last step. Now, just to sort of make sure everything's okay with this, let's check the first step in it. And so on the first step, they're changing the sign to 1 over cosecant in both cases, so that's okay. Now, in the middle step here, it's maybe kind of hard to see what they're doing, and you could actually work it out here. I'm not going to bother with it, but what they're doing is finding a common denominator. And when you find a common denominator, you would definitely get this value right here. All right, so our answer there is choice B. Okay, now this one's actually pretty simple. Just use a calculator to find this. Now the only ones that would be kind of difficult with this would be inverse cotangent. So with inverse cotangent, we might look at that here in just a second, but this one, I'm not even gonna work it out. You just throw in the calculator. But now let's go back to what if we do this? What if we do the inverse cotangent of say 2? And so I can find this one pretty simple by doing the inverse tangent of the reciprocal there, so it would be the inverse tangent of 1/2. Now, that would be okay because those are definitely going to be in the first quadrant. So I could actually just punch that in my calculator. Now, if we were doing instead the inverse cotangent of -2, then we're going to have an issue with that, because inverse cotangent would be negative in, or tangent would be negative in the second or fourth quadrant. Well, cotangent can only exist in the first or second quadrant, and the answer would have to be in the second quadrant. And the problem with that is inverse tangent is not. So we'll see if you guys can kind of remember how I would do this. So I would do the inverse tangent of the reciprocal, but then I'd have to modify that. So see if you kind of think there, I mean, how would I modify that to get the right answer? And so I would have to add pi to put it into the second quadrant from the fourth quadrant to make it fit inverse cotangent. Okay, next one, we've got another identity here. Just kind of looking at it, this looks like maybe a good split one because I've got that single denominator there. Now let's look at the last steps though. So let's see. Actually, we could probably get away with the first step on this. All right, let's look at the first step. And so basically what they're doing is they're splitting. And so when they split, though, I'm noticing a problem with the first step here. Let me think about this in just a minute. Yeah, what I was looking at there is they're actually splitting it incorrectly on the first choice. Now, let's go ahead and just go with maybe the last one here. And so on this one, no, I noticed what was wrong on that one again was the first step. They split this incorrectly. And so if you're going to split this, what this is going to give you here is you could say